this year's keynote talk. I'm very excited about it. NASA and Semantic Mediawiki conference go back at least until the year 2014, because I think this was the year when the first presentation of the EVA wiki was done by Darren Welch and James Montalvo. That was back in Vienna. By coincidence, that was the conference that I organized, because it was physically held in Vienna, and this was the first time I organized a Semantic Mediawiki conference. And now we are back with someone from NASA. Let me introduce to you Rich Evans, a fierce thinker and really a sparring partner for me also, in advocating Semantic Mediawiki and Semantic Web, and staying on track here with us. So I'm really, I have heard a little bit what he's going to talk about in previous calls. So I'm really excited to have him here. Without further ado, Rich, the floor is yours, and I'm really very happy and grateful that you are here and sharing our thoughts with us. Thank you.
Well, thank you, Bernard, good morning from the East Coast of the US. Special thanks to Bernard and Ad for organizing SMWCon Fall 2021. It's an honor to be part of the conference. This is actually my first time attending SMWCon, and it's amazing to me that doing this for the first time to have such a prominent speaking position in the conference. So I will try not to disappoint. Bear with me, as the Hopin software is new to me, and so I'm a little disoriented. But I'm going to try to do my screen share. And if I could get confirmation that that my screen is now showing. Okay, thank you. All right, so I titled the talk, Why NASA Uses Semantic Mediawiki and Why You Should Too. It's a provocative title, it's meant to be. And before we go too deep into it, I want to put a few disclaimers out. When I refer to NASA, I'm referring to the NASA Glenn Research Center Armstrong Test Facility in Sandusky, Ohio. And so I cannot speak for the agency as a whole. Implied there is why my part of NASA is using Semantic Mediawiki. And so this talk is a collection of charts that have been very successful with my management and with my peers. And so myself, Lexi McGillivray, and our team at ATF have been advocating for Semantic Mediawiki and have made some interesting progress in its implementation. And so I'd like to tell you about that. So the disclaimers are, so I'm not an academic, I'm not a historian, I'm not a professional software developer. I'm a boots on the ground test engineer, and for me, the ability to manage data has been a critical part of being successful. And within the agency, we have certain agency-wide tools, we have certain data management tools that are provided by our center. But I have found that the Semantic Mediawiki platform is a fabulous platform at the test site level to manage the type of data that our organization runs off of. So the goal of this talk is meant to be an easy to follow, fun overview of the concepts required to understand Semantic Mediawiki. Like I said, these charts were developed in order to communicate what we're doing to a non-technical group of people. But at the same time, I'm trying to make clear what the case is for why Semantic Mediawiki and not any of the other more prominent solutions that show up in people's radar when you talk about data and content management. Finally, some of my statements may be a little over the top. They're meant to make a point. If you want to call me out on the complete accuracy of what I'm saying afterwards, I'd be delighted to back out of some statements that might be somewhat hyperbolic. And most of the material, the images, are modifications of things I found on the web. So if I have used one of your charts and failed to give an attribution, please forgive me. I would be happy to correct that going forward. A quick introduction to where NASA is. And so most people are familiar with the term, but not everybody knows where you would go in order to knock on the door at NASA. We operate 17 different campuses across the continental United States, and there are 2 in north central Ohio. The Glenn Research Center in Cleveland, Ohio is our parent campus, and where I work is the Neil A. Armstrong Test Facility, or what we call ATF, in Sandusky, Ohio, and we're a remote campus where we have some very large test facilities, and we test spacecraft for the agency and our private industry customers. To our customers, we're a 6,400 acre spaceflight research campus in rural Ohio, near Lake Erie. We have some of the world's largest and most powerful spacecraft test chambers. For the purposes of today's talk, I want you to think of ATF as roughly 120 technical and non-technical knowledge workers operating approximately 6 very complicated test facilities. We're trying to do more with less in a world where if your budget stays flat, that's about the best you can hope for. We're trying to comply with federal directives to move away from paper records and to only have electronic records. We're trying to modernize our methods according to best practices advocated by the federal government. And all of that is bundled up with the idea that we are opting to run a local Semantic Mediawiki server within our campus for all of our knowledge management needs. The project began in 2009 and has recently really taken off. So I have set this talk up in 3 acts, and so I want to walk you through defining what we think the problem is. We'll talk about Act 2, which is understanding knowledge graphs, and then I'll try to tie it all together and show you how we're actually putting it all to work. So I'd like to begin with orienting us all at a place that we can hopefully recognize and sympathize with each other on, is that we live in a world where every day there is an ever-increasing amount of data that we are being asked to deal with. And so there is some amount of efficiency at which we can handle that. And so this graph is showing our efficiency relating to the amount of data. And the trajectory that we see here is that in the early days of the PC and the original internet, there was always a positive slope that as the data increased, our ability to deal with it was getting better as the information processing technologies improved. But then somewhere around the 2000s to 2010, we began to feel this inflection point, where as the data continued to increase, we began to get overwhelmed by it, and our ability to manage all that data is becoming increasingly difficult. And so the idea here is that there is a concern that we can't manage all the data. Well, so that was the actual knowledge worker. The knowledge architects, whose job it is to provide the solutions to the workers, they have been in this business for a while, and they've heard lots of different hype come and go. And so I wanted to talk about, from a knowledge architect standpoint, the idea of hype fatigue, where, in the industry, there's these buzzwords, people get excited about them. And just as a real quick cursory history, that beginning in roughly 2001, when Tim Berners-Lee made his famous article to the Scientific American on the advent of the semantic web, there was tremendous interest in a technology called ontologies, and DARPA was involved in trying to figure out if they could ontologize the web and create a global standard where all concepts would appeal to a universal ontological framework. And so that became a hype that promised a lot and didn't produce. And it was followed up with the hype of linked data. So roughly around 2006, when people were thinking that ontologies were too hard and too cumbersome, but they had developed the RDF protocol, and the idea was that basically, if you just take your raw data and use RDF as a way to get raw data out on the web, then if everyone adopts those principles, then linked data will solve all of our data management problems. And these charts are really a summary of information that was recently presented by Professor Pascal Hitzler in a recent keynote speech. So I want to thank him for that. And so this is the idea that the knowledge architects trying to put together solutions are dealing with hype fatigue. And so this brings us to what is the current hype. And we go to in roughly 2012, when the linked data hype was subsiding, Google had announced, after they had obviously become the world's most popular search provider, the idea and usefulness of knowledge graphs as the technology behind their groundbreaking search capabilities. And so everyone wanted to do what Google was doing. And so at some point, every knowledge management architect in every organization was asking the question, how can I benefit from this technology in my organization? Well, the promise of the hype is that it will restore us. It will turn us away from the negative slope of decreasing efficiency as the data goes up, and it will put us back on the path of increased efficiency. So that's the promise of the hype. And when we look at the technology, the knowledge graph technology, what we realize is that it really is just a combination of the best parts of ontologies with the best parts of linked data, rebranded with a new set of principles. And so knowledge graphs were born the knowledge graph hype was born in 2012, and it really separated everyone into two groups. So either you're doing knowledge graphs and your ability to handle data is increasing, or you're not doing knowledge graphs and you're in trouble. So the question was, how do we get everybody onto the green graph, onto the green line? And so that was as the knowledge graph is really just a return to ontologies, and ontologies in linked data is a return to the semantic web that was originally proposed back in the early 2000s. So the question then is, well, how can I have a knowledge graph? And so paraphrasing the situation for small businesses and open source users, they're told, well, it works very well, and there's a whole bunch of scientific computer science white papers. When small companies and open source users try to do it, hey, unless your organization has lots of data scientists, your best bet is to let some proprietary cloud service provide it for you. And so for open source users, the idea was knowledge graphs are a big data phenomenon, and so it's only for big business. Yet we want to point back, as I hope this community knows, that roughly around 2005, when the hype was dying off for ontologies, in an unrelated instance of progress, we saw the first release of Git in 2005, and then the GitHub service came online in 2008. Also in 2005 was the initial release of Mediawiki as part of the original ontology technology development. And so while you did have some version improvements and feature improvements along the way, it wasn't until after 2012, after the knowledge graph hype begins, that we see Semantic Mediawiki version 2 advocating for improved RDF support. And recently in 2018, version 3 brings us elastic store support, which I think is still a feature that is not fully fleshed out, but I think the basics are there. So what this says to us is that for the open source community, Semantic Mediawiki, if it's not the only, it is certainly the best mechanism available for open source users to participate in the knowledge graph phenomenon. So we move into understanding what knowledge graphs are. And before we dive into ontologies, I think it's important to show how the World Wide Web Consortium, the W3C, is charting the progress of internet technologies. And so this is a retroactive understanding. And so down, I think this was in the early 2000s, they looked back and they began to realize that there are two fundamental dimensions that you can categorize the emergence of new information processing technology. The first dimension, which we'll show on the x-axis, is the semantics of social connections, or the increase in the software technologies that can manage user content and user activities. And then we have also innovations and new technologies in software that allow us to better manipulate individual bits of data rather than full documents. And so if you take all of the technologies that have emerged since the PC era and you plot them on this two-axis chart, then you can imagine an idealized diagonal line where, in a perfect world, the technology is progressing, and so each time we get these new innovations, they're progressing us further to the top right section of the graph. Now, this is the idealized way to look at it, but in reality, the actual path in which the way these things emerged was not straight. So from the birth of the original internet, we began to see a lot of innovation in how to handle and process user-driven content and behavior. And that took us over into the right-hand side of the plot, and still low in the semantics of information connections. And this is basically the birth of the social web. And so where the emphasis is on understanding your users, paying attention to tracking their habits, their preferences, and their behaviors. And so all of the semantics of managing the social connections of user content and activity. But then in 2001, with the Tim Berners-Lee announcement of the Semantic Web and the push for ontologies and linked data, it began to drive innovation so that we were focusing less on social software and more on how do we pay more to, how do we manage the data in the documents and dissolve the lines between documents. So instead of a web of documents, the aim of the semantic web was to make a web of data. And then in 2012, we have this turn when Google announces knowledge graphs, and then that puts us back onto the final path, which is trying to get us to what the W3C is calling Web 4.0. And so this zigzag evolutionary path of the technologies in retrospect allows us to understand the evolution of the web in terms of 4 generations. And so from the original web of documents, we saw the social web come online. And while the social web is still flourishing in our everyday lives, everyone who is managing the data is bringing online the semantics, the semantic capability behind it. And when you merge the two with knowledge graphs, It's moving us towards Web 4.0, what the W3C is calling the ubiquitous web. And I just want to point out that we have semantic wikis listed as a Web 4.0 technology. So here's the original statement that the semantic web is not a separate web, but an extension of the current one, in which information is given well-defined meaning, better enabling computers and people to work in cooperation. And that's the real point that the rest of this is meant to showcase, that that we want to live in a world, or make a world, where the computers can assist us in all of our aims and goals. And as it is right now, the computers assist us simply by hosting the data, but with the promise of the semantic web and what knowledge graph technology can do is to make it so that machines can make sense of data and assist us in managing data in ways that we would do ourselves if we were doing the interpreting on our own. So we want to start with a review of what the historical ways of storing data on the internet have been. So prior to the semantic web, data as content is stored in two basic ways. We have unstructured data, which we're all familiar with as text. Data as documents, you take whatever it is you're thinking, whatever it is you have to say, you write it in a sentence, and the advantage of this is that it's readily readable by your peers. So the context of what you're saying is really in the mind of the reader, and the computer does not participate in this at all. But we do want computers to help us manage data, so we abandon our unstructured data and we begin to build tables. And the advantage of tables is that you can design programs that can access the data in the tables in predefined ways, and off you go. You can build very powerful data processing applications. The problem with merely structured data is that any particular value taken out of the table itself loses all of its context. So the data is only meaningful if it is in a table, and the tables are very specific in terms of how they see the world. So the tables are designed for a purpose, and so they're not very adaptable to purposes that were not originally envisioned. And that's why all database schema developers will groan when, after they have developed the database schema optimized for the solution that they were told to program for, if down the road there's a paradigm shift in the way that data is used, it really involves a rewrite of the schema, which is a very complicated task. So structured data is great, but it's not as adaptable as it needs to be to handle the dynamic world of data that we're merging into. The obvious technologies are, for unstructured data, Word documents and PDFs and emails, and for structured data, we're all familiar with spreadsheets and databases. So the real moment of progress in the semantic web is that it's an introduction of a new way, a fundamentally new way to store data on the web. It's neither unstructured nor is it structured in the way that tables are. That the semantic web is storing data in a method called web ontologies. And as I'm sort of previewing at the bottom of the chart, that the web ontologies are most commonly represented as knowledge graphs. And a web ontology was formally described in 1993 as a formal, explicit specification of a shared conceptualization. And over the course of from 2000 to 2012, and even today, the RDF framework is being maintained. I think it was originally developed in '97. Version 2 came out in 2012. And so the main takeaway here is that we're not we're storing data where the data is the context. The structure of the data is the context. To elaborate a little bit about this, an ontology is pure structure without any explicit content. So an example, or it's basically any two concepts that are related by a named relationship. And when you have this this fundamental cell of an ontology, it's a subject predicate object relationship, and when you apply data to it, when you actually put values into the ontology, it becomes a semantic triple. So for example, the ontology, which is pure structure, could be expressed as person works for company. The actual knowledge in the knowledge graph node would be John as a person, works for as the predicate, and for example, NASA as the company. And so then we could say John works for NASA is in the ontological structure of what a person is. And we can replicate this way of modeling concepts can be expanded quite easily. So if we say that users are concepts that can work for companies, then the knowledge graph becomes an instantiation of one or more ontologies. And it doesn't have to be a single triple. You can merge multiple triples into a single ontology, so that user has given name, user has email address, and so forth, that each of these is an individual semantic triple, but they are combined into a single ontology. Now, the instantiation of that ontology would be, as I've shown here at the bottom. And this is all fairly basic, but what gets interesting is if you have if you're done elaborating on what your user ontology is, but you want to say a little bit more, you want to define your company ontology, you may want to say that companies have locations. So you would take the ontology of the user and you would add to it the ontology of the company, which has location site. And within the instantiation, these two ontologies are purely additive. And so the company ontology has a subject, predicate, object relationship that participates in the graph at the same level as the user ontology. So these two very different concepts, which have their own independent ontologies, can actually coexist in the same knowledge graph at the same level. And of course, in the same way that the user ontology has multiple predicates and objects, we can also replicate, like we can say that if the company ontology has multiple locations, it's as easy as creating duplications of the relationship for the same subject node. So how does this transform the web? So we begin by looking at what the web was prior to semantics. And so this is a picture of what the web of documents, Web 1.0, looks like. It's a collection of documents that are all available, and they all contain links pointing to each other. And this is an example of purely linked data with no ontologies. And so the idea then is that you could ask questions like, well, how many nodes are in this network? How many links are in this network? You could do some kind of analytics, but at the end of the day, you don't really understand what information is contained here. So search is done simply by brute force word search. Ranking is done by word frequency. This is not going to provide us the efficiency that we need in managing ever increasing amounts of data. So if we convert this graph of documents and we begin to understand that each document has a name and we can catalog these things, it's a minor improvement, But this is what, for example, Wikipedia might look like to the everyday user. Now, this is not to, I mean, I fully acknowledge that Wikidata is out there and is managing the wealth of knowledge within the articles, but to the end user who's just browsing Wikipedia trying to find information, they still have to manually process what they're interested in, and they have to interpret why the links are there, and they have to decide whether they want to follow them based on the knowledge that they have in their head. So what the semantics do is they transform the links. So notice that all of these nodes are connected by a gray line that simply says links to. And we don't really understand why those links are there. In order to understand why the links are there, we would have to read the document and make that determination ourselves. What the semantics do is they augment the links so that the reason why every link is there is not only understandable by the reader, but it's also interpretable by the machine. So now you can go out with a true semantic web. You can go out and you can collect all the different nodes, all of their unique names, and you can understand not only which nodes link to each other, but why they link to each other. And this is really the first instantiation of a knowledge graph. And we can see that this knowledge graph, even though it's more complicated than what we showed previously, every two nodes connected by a semantic predicate conforms to the fundamental elemental cell of an ontology. Paris is a city, is an ontology. Eiffel Tower is located in Paris, is a semantic triple. Bob was born in July 1990, is a semantic triple. And so the entire knowledge graph is really just a collection of these semantic triples. So much so that we can take this, this intuitive graphical graph and we can write down every one of those triples. And if we do so, we get something like what you see on the right. And it's on the right is basically a table, which is a ledger of the semantic triples. And so we can see that if the Eiffel Tower is located in Paris, we can write that down as a semantic triple statement. And again, every semantic triple conforms to the ontology, subject, predicate, object. And so what we have is a way to express the same knowledge in two ways. On the left, we have a graphical representation. On the right, we have a purely textual representation, but they are mathematically isomorphic. So from the list of semantic triples, I can generate the graph, and from the graph, I can generate the list of semantic triples. So this invites me to wonder what one node may have to do with another that it is not directly connected to. And so one of the really interesting things that you can do with a knowledge graph is you can take two arbitrary nodes and you can find any path in the graph that connects them. Now, graphically, that's intuitively obvious, but it's not intuitively obvious from the triple store, but that's okay. The algorithms exist to make quick work of it anyway. So while for our minds to figure out how to trace a path from Alice to Paris, we would be able to do that intuitively from the graphical representation of the graph, but the computers are actually much better suited to figure out this path by analyzing the triple store, the text in the triple store. But what's the point of doing this? Why would we want to? Well, if we think of the knowledge graph as being laid flat, then we can identify the two nodes that we're interested in, and we can ask the fundamental question, what does Alice have to do with Paris? And in the triple store analysis, we can lift those two nodes of interest out of the graph, and the path that connects them can be followed and interpreted, and everything that connects Alice to Paris is an insight that was not initially programmed by the person who edited any individual or all of the nodes. So what we're discovering here is that the knowledge graph contains knowledge that was not intentionally programmed into the system. So for example, by simply asking the question, what does Alice have to do with Paris? I can learn that Bob is interested in the Mona Lisa, and I can learn that the Mona Lisa is exhibited at the Louvre, and I can learn that the Louvre is located in Paris. And so all of the links in the chain between any two nodes of interest become valuable insights. And this is the primary advantage of the semantic web. That's what capturing your data as knowledge in a knowledge graph and expressing that knowledge in a triple store and having the ability to analyze that triple store gives the organization the ability to learn things that it did not know explicitly. Now, Google made this famous, or Google did this so well that they became the dominant search provider, and they became a household name. And so the question is, can we do this at the small business and open source level? So if you can do this, then you can be part of that group of users that is able to manage tremendous amounts of data with great efficiency. And if you can't do this, you will be on the lower part of the graph struggling with increasing data. So fortunately, the open source community has had Semantic Mediawiki since 2005, and it has seen many major version increases and feature improvements, and there's a whole ecosystem of supporting extensions, and at the end of the day, what we're able to say is that as recently as 2020, the computer science, the world of academia, as I understand it, has formally defined what a knowledge graph is. And so the knowledge graph definition in the scientific literature is represented by the work of Sack and Alum, and they've identified the core properties of a knowledge graph. This is 8 years after Google announced the technology, and Semantic Mediawiki complies with that academic definition of a knowledge graph, does so with conformance to the RDF protocols that are defined by the World Wide Web Consortium. So it is perfectly staged as if not the only, the best open source software for instantiating knowledge graphs in a user-driven environment. And so NASA Glenn Research Center Armstrong Test Facility has been using Semantic Mediawiki since 2009. It is the basis of our current approach to knowledge management. This brings us to the final act, and my opportunity to show you exactly how we're doing this. I want to start at a philosophical level and say that our ultimate goal is knowledge management, and the ability to manage this increasing amount of data and getting the right data to the right people at the right time is how we measure our efficiency. And the knowledge that we create is defined by the useful connections that it has in our systems. And so we look at all of our knowledge activities, and we see that it exists as a collection of people, processes, and technology. That's our definition of knowledge management. And the idea then is, when we look at the problem and we see that there is decreasing efficiency as the amount of data increases, we claim that the problem is not that we don't have wonderful workers, not that we don't have really great processes. It's that our information handling technology is not as well integrated with the people and the processes as it needs to be in order to handle the data. And as a result, that turns the knowledge management activity into a fourth entity. And this is incredibly inefficient. So for example, if we have a project document that needs to be updated, you may have in a library, you may have the document for document configuration management beautifully specified in a company document, and it's out there in the company library. And you may have the actual document itself living in a project data silo. And then you may have the people who are responsible for following the process, developing the updated version of the project document, posting the updated version unbeknownst to anyone. So the idea then is that if I download the new version, I will find that it does have a version history. It was updated in accordance with company policies, but really the announcement that the document's been updated is handled verbally or by email. And even though the document itself has a revision history page within it, and it conforms to our document management requirements, we really don't know who actually posted it. We don't really know who actually edited it. So this is an example where our people, processes, and technology are independently, they're independent of each other, and then knowledge management is an additional task that takes additional time and additional resources to perform, which is one of the reasons why it isn't always done as well as it could be. What we can imagine with the semantic web is that if we are capturing our knowledge in a knowledge graph, in a semantic web application, then instead of thinking of knowledge management as a fourth activity, we can think of it as the medium in which the people, processes, and technology take place. And so now we can, if we can do this, then we can benefit from all of the power of the semantic web. We can be back on the positive slope of efficiency, and we can be positioned to benefit from the future of business intelligence and agent reasoning, the intelligent web that is to come. And an example of this is going back to the example of updating a project document. If our processes for updating the document are all built into an electronic workflow, and the need and the document content itself is all part of the same system that workflow functions in, and the activity of the users are all timestamped and logged, available for audit, then you have the ability that users at all levels can see what's happening in real time. Dashboards can be built to show activity in real time. We're basically utilizing all of the back-end data of what is happening in the system to understand not only the content of the new documents, but the process of how it's being done. So this is an example where knowledge management is not, the people, processes, and technology are well integrated with the semantic web, and knowledge management becomes the medium of the work and not a separate activity. So how do we do this? Because we are not reaching out to major proprietary cloud services. Well, so at the very bottom, within our organization, we have some physical hardware. We have a server on our intranet that we maintain. That's the red base of the triangle. And then on top of that base, we begin to build our software application stack. You guys will recognize much of this. So the traditional LAMP stack, which is Linux as the operating system, Apache, MySQL as the backend database, and PHP as the scripting engine. And then we get Elasticsearch, which is the open source triple store search tool, provides the application foundation. And then within our agency, we have a couple of plugins for authentication and authorization that allows us to make sure we know who our users are and manage their roles and permissions outside of the application. Mediawiki is, of course, the wiki application. And with Semantic Mediawiki and all of the other extensions added on top, provides us a completely free and open source application software stack Some of my colleagues originally thought that we were just developing a local NASA wiki, which it certainly is from the front end. But I got into the habit of calling it wiki on steroids, because what we are also able to do, because of the semantic extensions, MediaWiki gives us the ability to categorize our pages and develop templates. Categories allow us to map pages into specific ontologies. Templates allow us to standardize how pages look so that our users are not faced with a blank page trying to author something from scratch. And we collect data from the users using forms. And so page forms is a critical component. Without page forms, the users would have to edit pages as narrative. They would have to encode the semantics manually. So with forms, with page forms, we have the ability to, instead of asking a user to edit a blank page or edit a page as text, we have them edit it with a form, and then they just fill in the values as they're supposed to. And we curate the nodes of our network with forms and templates. Behind the scenes, the templates then categorize the pages, and the templates then also encode the form data as semantics in property pages. So again, we have we pay for within the organization. It does take a little bit of money to have a server on the organizational network infrastructure, but on that server we have a completely open source software stack that gives us the ability to develop the wiki page content, and then by developing these content pages, we are ontologizing everything in our world. We're ontologizing our users, we're ontologizing our customers, we're ontologizing our documents. Everything that we talk about in our day-to-day meetings gets ontologized in the wiki. And then what that allows us to do is implement 100% electronic workflows within the MediaWiki application framework. And so MediaWiki by itself does not have this capability. MediaWiki plus Semantic Mediawiki plus additional extensions like page forms and others allows you to implement BPMN business processes in the wiki environment with all the benefit of being able to maintain your processes as wiki articles. And you can also maintain the objects of those processes. The tasks, the documents, the projects are all maintained as wiki documents as well. So it's a 100% wiki article driven electronic workflow modeling BPMN processes. And in the background, we get a knowledge graph. And so an example of a specific example of how this is used in our world, one of the primary things that we do is we perform space environment testing on spacecraft for our customers. And so within the course of a year, we are initiating and performing and concluding test projects or facility projects. And so an example of ontologizing that work is that we have a page which is categorized as a facility project. And when the user edits that page, there is a form that asks them to specify who the customer of the project is. And so in supplying the name of the customer, when that form is saved, the template then renders that customer data as semantic data, which creates the property, which gives the property has customer the value SpaceX, which allows this page then, which is edited with forms and displayed by templates, standardized input, standardized output. The users are editing the data, and the data then is being encoded as semantics within the template, and that's editing the nodes of the knowledge graph. And so we have our subject, predicate, object structure of the semantic triple. We have the article, which is SEC PRJ 2021-001, is an instantiation of a facility project that it has in its ontology. The property has customer, which is the predicate, and encoded in the page is the data, SpaceX, which is an instance of a company, which is the object of this triple. And so this allows us to begin to not only ontologize our projects, but now we can ontologize our customers, and we can ontologize the test facilities that we operate at. And all of our test facilities have their own articles. All of our customers within our wiki have their own article, and all of the work that we do at our facilities for our customers is all bundled up in its own article of instances of different projects. What this allows us to do as the weeks and months and years unfold is that we begin generating articles on our customers, generating articles on our projects, generating articles on our test facilities, and many, many more things that we have ontologized. And so then that allows this knowledge graph to be developed in the background. This allows us to convert a mirror web of linked data into a fully qualified knowledge graph system that checks all the boxes for conforming to the SAC-ALUM 2020 academic specification for a knowledge graph, which positions us in a place that makes it where we are ready to move to the to Web 4.0, and we're ready to start using agent AI business intelligence and implementing back-end intelligence. So quick examples of what we can do with the knowledge graph. In addition to merely collecting data from the forms on what the subject matter is, once that data is collected and the user hits save, that data can be used to ask predefined questions that may be pertinent to the particular topic of a facility project. So we can build dashboards where we can analyze all the status and history of all the projects, can be reviewed by management. The individual projects have insights from Sparkle queries that are embedded in the templates. We can automate the routine creation of reports by every at whatever interval we define. We can have Python scripts go out and browse the web on our behalf and put together the relevant data into reports. We can bring data in from remote sources, and we can develop server-side scripts that decompose the remote data connections into the individual data pieces, and then goes out and edits the articles for us. I could talk at length about that. And lastly, what we're excited about is the ability to implement natural language processing. So when we talk about having the knowledge graph and what we can position ourselves to be able to do going forward, is that this technology will allow us to expand our server software model to include additional tooling in the future that can handle natural language processing for ad hoc queries on demand. For all of the questions that we can anticipate people asking, we can hard code the Sparkle queries. But for the questions that we cannot anticipate, which is an important part of life, we hope that the natural language processing can be of benefit. So a few closing remarks. I've put together a list of 10 takeaways. I won't read them all. I won't read them top to bottom, but I just want to end by pointing out that Semantic Mediawiki is an essential part of an all open source software stack for any Web 3.0 knowledge management platform that hopes to be part of the web, the knowledge that hopes to be part of the transition to Web 4.0. Special thanks again to Bernard and Ad and others who have put together this conference. I'm really looking forward to hearing all of the other talks these next couple of days, and I want to leave you with a challenge. So my challenge to all of you is that you can have the exact software stack that I have been presenting running on your system today in presumably less than 2 hours, using Oracle's virtual machine and a one-page procedure that we have that I have made available on mediawiki.org. And in your spare time, I challenge all of you to run this software using the Ansible project Mesa, which will install the whole thing on your system for you to experiment with. And so I'll leave you with that. Thank you very much.
Thank you very much, Rich. That was in my opinion, excellent keynote talk that sets the stage for this conference very well. I cannot wait to put the recording of this online because it's a great introduction to so many topics, from semantic web to knowledge management and all that. So that was really amazing. We now have time for questions and discussion. You have two options. You can use the chat for your questions, and I will read them aloud, but also you have the opportunity to connect with audio and video and ask your question yourself. So Franz van der Horst is, I think, the first one who I hope intentionally clicked here. So I will now add him and he can ask his question.
Well, I'm not posing a question. However, it was a very nice presentation. I unintentionally pressed the button because I thought I had to do so because I'm going to give the next presentation.
Oh, okay.
So
you don't have a question
to your others, please.
Okay, then I will remove you again. Any other questions from the audience? I don't see anything in the chat. If not, I would have a question. Just out of curiosity, when you started introducing Semantic Mediawiki for your use case, did you already have a wiki or MediaWiki, and then you added Semantic Mediawiki on top of that, or did you start with all the semantic and forms-based type of working, which is actually quite different than having a plain MediaWiki installation and users, typing articles? So what was first?
So my introduction to MediaWiki by itself was first, but Semantic Mediawiki, I think I discovered that in 2008, and I really have never known. I have never known MediaWiki without Semantic Mediawiki. In fact, I would say that for my purposes, it has been the reason why I need a wiki. I don't know. I'm trying to figure out if I should elaborate more on that. So,
yeah. Go ahead.
Well, so I'll say that my original the value that I saw in Semantic Mediawiki back in the early days, I knew nothing about knowledge graphs, nothing about ontologies. So to me, it was just a way to store data in a page. And so I would say that 90% of what we understand the value of Semantic Mediawiki to be is really as just a way to store data in the page that has a particular way of querying it back out. The idea that there was this knowledge graph capability in the background was unknown to me until probably around 2016. And as I began to try to understand that aspect of it more, it occurred to me that I chose Semantic Mediawiki for the fact that I could store data in a page and query it back out. But now I realized that it is the enabling technology that positions us to move our processes into where the web is actually going.
Mm-hmm.
So I'm excited about the future aspects that I'm excited about are trying to get like Neo4j up and running alongside, and we can implement some kind of a background knowledge graph analysis tool and try to get vocabularies and synonyms put together so that we can try to get cobble together something that does natural language processing. So there's a lot of exciting next steps to take, but having a platform in place that the users, the everyday users who are not interested in IT, they don't think about this in their spare time. They use it as part of their job, and they want it to work simple and well, and they want to be able to find their stuff. That aspect of it works fantastic, and trying to tap into all of these additional great features, great capabilities is the next area of work.
Mm-hmm. We have a couple of questions now on the chat, and even some likes for good questions. So I'm gonna just continue with one. Jeff Scott writes, I'd be interested to know how you encouraged or forced people to move using Semantic Mediawiki instead of traditional Office applications.
The answer is that it's a blended environment. So we are still heavily dependent on Office documents. There is another talk that I could give on how we implemented a Semantic Mediawiki based file folder management system. So one of the biggest challenge for the traditional Office document users is that files on a wiki are in a flat file structure. And so readme.txt is one and only one file on a wiki, whereas many people have different readme.txt files in many different folders. So we had to come up with a way. I would say that the bridge, the real event that allowed traditional users to buy into this was when we provided them with a way to emulate nested file folder management within the wiki that doesn't rely on any special extensions. And so I actually presented, I think at SMWCon a few years back, I gave a presentation on that, and I would say that is a prerequisite to getting traditional users on board.
Mm-hmm. And there's an additional question that would fit very well now. And how was the management convinced? Did that go easy?
It has been a long journey. So this was a passion project for a long time, and I was using it successfully to manage my own work. And then there was an opportunity where we had an incident, and there was a corrective action plan, and we were brainstorming ways, we have to prove that our processes are always improving and that we won't repeat the mistakes of the past. And I proposed to management that if we adopted this platform for this particular activity, and it turned out to be internal document management, that we would never have this problem again. And we treated it as a pilot project, and people were apprehensive. They were concerned about the sustainability. And so over the past 3 years, we have done a number of pilot projects. Management's confidence in the system we have succeeded at every pilot project, and we are slowly, one opportunity at a time, absorbing the legacy document-driven processes. And so we started by the first major accomplishment was to get management to allow us to try to officially manage our documents. to let the wiki be responsible for generating unique document IDs, to let the wiki be responsible for keeping track of version history, and let the wiki be in charge of hosting the official versions. So that document management workflow implemented in the way that I described here was the game-changing event.
Okay, thank you. We're a little bit running out of time, but I would like to one more post one more question from Gregory.
Oh, hi. I don't know if you can hear me, but
yeah.
I was just wondering, once you have forms and templates associated with a category or a concept, then how does a new user come in, and how do you effectively allow that user to create new content, from the myriad of forms and concepts and things? So, yeah.
So there's a great answer to that. So we're also using, we also have, within NASA, we still have all of our procedures and processes formally documented. So the use of the wiki is now being baked into all of our official procedures. So a new user would find the link on what they're supposed to click on from the procedures that they're formally required to follow.
Great. Thank you.
Okay, thank you very much. Yeah, thank you, Rich. I would like to leave it here. Maybe you can paste the link for your challenge in the chat, and maybe you can also answer some more questions in the chat or later during the breaks. I hope you will be around for, maybe we can meet you in the coffee house or something like that, where the other people can still ask you the questions.
Yep, I would love that. Thank you again. And so while this particular presentation environment is new to me, how do we refer to it? Riot, Elements. That's where I'm most active, and I'm happy to answer questions on any of this at any time. So hoping to get to know all of you better, and thanks again.